Okay, so Tony had a reasonable question, which was basically, it seems as though we can't solve any second order DEs. Right? Because what kind of second order differential equations do you actually know how to solve?
Constant homogeneous.
Yeah. So, like right now, techniques I have, right? Like I know how to solve separable things. I know how to solve like some linear first order stuff. Not actually all of it, but like some of it. Right? And then, let's see, what else did I learn how to solve? I learned how to solve some first order nonlinear, but not very many. Oh, and I said I couldn't solve all of these, but I think we can solve all of those at least on reasonable intervals. And this includes homogeneous and non-homogeneous, right? Like either way I'm okay. So I'll use variation of parameters or whatever to figure it out. So first order nonlinear, I have like
Bernoulli's and the y over x.
Yeah, like some of them. And I know like Bernoulli, I know the y over x ones. I could maybe try, yeah, I have exactness. I could maybe try to reason my way through some others, like by guess and checking, or just like hoping variation of parameters is going to work for me. Like sometimes that'll be an option. Like so maybe some like grab bag of others. But then when I get to second order, right? Like right now, all I have is second order linear with what?
Constant coefficients.
Yeah, with constant coefficients. And if you look through the sections, which I think is where this question came from, right? You look through the rest of the book and you were like, dude, chapter 5 doesn't talk about anything else. It only talks about constant coefficients, so what the heck? Like, sorry man, that's what there is. So in this chapter, what we're going to get is we're going to get second order constant coefficient, and we're going to get homogeneous and non-homogeneous. Well, some of these anyway. Right, which feels like really actually in the grand scheme of things, I'm starting to not know how to solve things. And that's really what's going to happen. So what we're going to do after this is we're going to do a chapter on applications, like how to actually like get the second order differential equations out of springs, right? And then we're going to solve some of those, and we're going to like maybe look at some pendulums or some darn thing. And then after that, what we're going to do is we're going to develop a whole set of things that don't actually solve any one thing, but you can kind of try them out of desperation. Cool? So the kind of desperation tricks we're going to teach you are we're going to teach you a little bit about series. We're going to teach you a thing called Laplace transform. If you're clever, you can like go read a book and figure out other kinds of transforms that might be a good idea. The kind of usual is, anybody know what the other standard one other than Laplace is? No? Starts with an F.
Oh, the Fourier.
Fourier transform is another kind of standard transform that you might try. I just don't have time to cram all that stuff into one class. And then the other option we could do is we could like rewrite things in a system and then play linear algebra land. So like that would be another option. But these are basically your like kind of techniques we're going to get for the rest of the course. And otherwise we're not going to go to third order linear and figure out how to solve it. Like that's just not a thing we're going to do.
Are we going to touch third or fourth or anything beyond second at all?
Yeah, we are. We're going to do a bunch of higher order kind of thoughts. But the way we're going to do them is we're going to say, why don't we just turn them into a system or Laplace transform them and then deal with that? You could also hit them with series. But so right now, we're going to stop learning new kinds of differential equations to solve. We're just going to assume the rest are annoying. And then we're going to learn these 3 techniques that we could apply to any of those and see if they'll work. You guys see that? Does that kind of make sense philosophically, at least?
So basically, we're going to look at them, but we're only going to look at the nice ones.
No, so these 3 techniques we're going to learn to apply to really crummy stuff.
No, I meant look at the
Oh.
ones.
Yeah, the specific ones that we're talking about, we're going to do like easy stuff that we might be able to we might have a chance of solving reasonably. And then we're going to talk about higher order. But yeah, we're probably going to look at nice, convenient higher order things because I'm going to give you the idea of how to do these, but it takes a little bit of time and effort to get any one of these techniques working. So I'm going to show you how to do it, but I'm not going to spend a ton of time working on like this one really inconvenient example. Does that make sense? You could definitely do really inconvenient examples with these techniques. It'll just take a long time, especially that one. Doing series on anything is like, it's a great idea. Such a good idea. And it's such a pain in the ass to actually execute. Cool?